Welcome to Physics 310, and this is third video for chapter 2, and in this section we are going to talk about motion of body under the influence of gravity. So if we throw something vertically upward from the ground, okay, this is ground, and if we throw vertically upward, so this motion is motion in one dimension because it is moving vertically upward. You can say this is y-axis, moving along y-axis. So this is your x, this is your minus x, this is your y, this is your minus y. So if you throw something, this is moving upward, so it is going along plus y-axis. While it is going upward, or when it is above the ground, its motion is all the time controlled by, or its motion all the time is influenced by the gravitational force or force of gravity. The force of gravity creates acceleration due to gravity. We are not talking about a force in this chapter, but we will talk its effect. The effect of force of gravity is the acceleration due to gravity. It always works downward, means towards the ground, G. Okay, gravity is always pulling down towards the ground, and the value of G is 9.8 meter per second square for the earth. Okay, means when you go to the moon, the G will be different, or if you go to any other planet, the value of G will be different. But for this earth, the G is approximately 9.8 meter per second square, right? So when you throw the ball upward, okay, G will decelerate it. It will try to slow down, okay. As it goes up and up and up, it slows down, okay, because acceleration due to gravity is working opposite direction, opposite to the direction of motion. So while ball is going up, the G is slowing down, okay. So when it climbs more and more, eventually at the top it comes to rest, and from the top again the gravity is working all the time, so the gravity brings it down, okay. So from here it starts with rest, and then again it comes down. Its velocity goes up and up and up and up and up and up, and it hits back the ground with the same velocity what you have thrown, okay. For example, if you throw with velocity 10 meter per second upward, it will return back and hit the ground with 10 meter per second downward. Alright, if your starting and end point is same, then the velocity, the upward velocity will be same as the downward velocity at the ground. Okay, So, you know, we got to use the convention here that if anything we measure in positive y direction, alright, that will be positive sign. Anything is there in negative y direction, that will be negative sign. So when we put G, three kinematic equations, then we have to insert G as minus sign. Let us see what I'm talking about. You know, for horizontal, you have learned the equations. V final is equal to V initial plus AT. Okay, this is for the horizontal motion, where A is acceleration. Alright, in vertical motion, A becomes minus G. Okay, so this is for horizontal motion. And let's write for the vertical motion. Vertical motion in gravity. So what will happen? V final, in this case V final will become same thing, V initial, and in place of A we are going to put minus G. So it becomes minus GT. Okay, same equations, A is replaced by minus G. There was another equation, V final square is equal to V initial square plus 2A delta X. This equation will become V final square is equal to V initial square, same thing, in place of A you put minus G, so the A becomes minus G, so minus 2G. Now we are making all the measurements along y direction, so in place of delta X it becomes delta Y. And the third equation is delta X is equal to V initial T plus 1/2 AT square. This one will change to, in place of delta X, delta Y will be there. Delta Y is equal to V initial T minus half. A is replaced by minus G, so plus becomes minus GT square. Okay, so you know, if you know all these three, it is very easy to remember these three. Alright, the only thing you have to be careful, A becomes minus G. Okay, so when you make a transition from this side to this side, change A to minus G. I said earlier, if for extra clarity, since this is a motion in X direction, one can insert suffix here. V final X is equal to V initial X plus AT. Then this becomes V final Y is equal to V initial Y minus GT. This becomes V final X square is equal to V initial X square plus 2A delta X. This is for Y, so V final Y square is equal to V initial Y square minus 2G delta Y. This is delta X is equal to, this is for horizontal motion, so v initial x plus half at square. This becomes delta y is equal to v initial y t minus 1/2 gt square. Alright, so putting a suffix here gives you an extra clarity, and these suffixes becomes very important when we move to chapter 4. In chapter 4 there is a motion at the same time along x-axis and at the same time along y-axis. Alright, so these two equations has to be dealt simultaneously in chapter 4. So I am just writing in advance so you become familiar that you can add a suffix here. So this denotes that everything is happening along x-axis, and this denotes that everything is happening along y-axis. Alright, but even in this chapter, if you don't put the suffix, that's also fine. Let's see how we can use these equations to solve different problems. This is example 2.7. A student's book falls out of the window of the physics laboratory. How long does it take to fall to the ground 20.0 meter below? With what velocity does the book hit the ground? So let's try to sketch this. Okay, so here is the ground, okay, and here is the window of physics lab. You can imagine this is the window of a physics lab, and this is the book here. There is a book, it falls down from here. This is a book, this is window, this is window, and the book hits the ground. And how far below it goes? This is 20 meter below. This is 20 meter, 20.0 meter. And the question is velocity, with what velocity does the book hit the ground? So when it hits the ground, what's the velocity here? Now, what would be the initial velocity? When the book leaves the window, what would be the starting velocity? Though it is not written in the question, you have to think. With what velocity it leaves the window? It's obvious, it starts from rest. So v initial is equal to 0. Okay? And when it hits the ground, v final we are looking for. And how far below it goes? 20 meters. So you remember, this is your x, this is your minus x, this is your y, this is your minus y. So which direction it is moving? It is moving towards minus y direction. So delta y is going to be, though it is written here plus, but you have to think and decide. This delta y is going to be, since it is moving in minus y direction, change in position is in minus y direction. So this is going to be minus 20.0 meter. Okay. Now for vertical motion we have three equations. V final is equal to V initial minus GT. V final square is equal to V initial square minus 2g delta y, and delta y is equal to V initial t minus 1/2 gt square. Which equation should we apply to get V final? In fact, we have to calculate time also. How long does it take to fall to the ground? So we are looking for time also. Okay, let's find the time first and then we will go to the V final later. So which equation can give you the time? Now for the time, can we use this one? We have everything except time. We have delta y, V initial is 0 minus half gt square. So using delta y is equal to V initial t minus 1/2 gt square. This is minus 20.0 is equal to 0 times t minus 1/2 times 9.8 times t square. So minus 20.0 is equal to, this is 0 minus half of 9.8 is minus 4.9 t square. Minus and minus will cancel. So this gives you t square is equal to 20 over 4.9. So t is equal to square root of plus minus square root of 20 over 4.9. Okay, this t will be plus minus 2.02. You know the time is never negative, so we will drop the minus 1. So t is equal to 2.02 seconds. How about the second part of the problem? With what velocity does the book hit the ground? Okay, I have choice. I can use this one, I can use this one. If I need to use this one, I can use this t. But when I use this one, I don't have to depend on this part. I can calculate with the information given in the question. So let's not depend here on this t here. You know, if someone wants, one can do this, but the answer will be same. No matter how you do, your answer will be coming the same. Either you use this one or this one. So let's do, with what velocity does the book hit the ground? So this using V final square is equal to V initial square minus 2g delta y. Let's make this one separate. So what will happen here? V final we don't know, we are looking for, is equal to 0 square minus 2 times 9.8 times delta y is minus 20. V final square is equal to, this minus and this minus will become plus. So 2 times 9.8 times 20. How much this will give? This is 392. So V is what? Plus minus square root of 392. And if you take the square root, it will come V is equal to plus minus 19.799 meter per second. Now you have to make a decision. There are two choices: plus 19.798 or minus 19.798 meter per second. Which one is the correct one? Okay, you see this here in the diagram. This is going downward, so it is in minus y direction. When it is hitting the ground, it is going in minus y direction. So the correct answer will be V will be minus 19.798 meter per second. This is can be approximated as minus 19.8 meter per second. Let's do another example. One student holds a vertical meter stick near the top and then drops it. Okay, so you have someone someone is holding a meter stick at the top. Okay, the second student then catches it after the stick has fallen 23.5 centimeter. Okay, and so this is your ground. There is second student is here. And he is trying to catch this one. Okay, he puts it, he goes and grabs it. When he releases it, the second student grabs this stick, and when it grabs it, the stick has fallen. Okay, in fact they are in the same line. This one and this one, they are in the same line. I have separated them. Okay, when it is released, it is grabbed here. And how far is this? How far it goes down? 23.5 centimeters. So from the top, in this line it is grabbed, and it goes how much? 23.5 centimeters. So delta y, it is going in. So this is your x minus x, y minus y. It is going in minus y direction. So delta y is minus 23.5 centimeter. And if you change in meter, how much it is going to be? Divide by 100. So minus 0.235 meter. Okay. If you divide this number by 100, you can convert to meter. So using the kinematic equation for free fall, find the reaction time of the second student. Okay, so what reaction time means how fast he is going to grab it. If his reaction time is very fast, then this will be quite less. If reaction time is slow, the stick will fall more and this distance will be more. Okay, if reaction time is fast, if the reaction time is quick and fast, the stick will fall, the meter stick will fall less. If the reaction time is slow, it takes long time to catch it, then the stick will fall more. Okay, so for this particular distance, if the stick falls this much distance, how much is the time required to fall from here to here? That is the reaction time from the top to this point. Again, we have three equations. V final is equal to V initial minus GT. V final square is equal to V initial square minus 2G delta Y. Delta Y is equal to V initial T minus half GT square. One of these three equations will be used. Okay. One more thing I would like to say, what is the initial velocity of this stick when it starts from the top? V initial is equal to 0. Okay, we are looking time. So what are the options we have? We have this equation that contains time, this equation contains time. This equation has time, this equation has time. This equation has no time. If you see, there is no time in here. So we are not using this one. Now out of these two we have to make a correct choice based on the information we have. So let's see which one is the correct one. Do we have V final? No, we don't. So we cannot use this one because we don't have V final when the second student is catching the meter stick. So only option is left this one. So using delta Y is equal to V initial T minus 1/2 GT square. This is minus 0.235 meter. 0 times T minus 1/2 times 9.8, because G is 9.8 meter per second square. That's what we are using here. And T square. So this gives you minus 0.235. Okay. I'm not writing units here, but if someone wants, you can insert it. Alright, I have to make sure that all the units are in SI unit. All the lengths has to be in meter, all the distances has to be in meter, time has to be in second, G has to be in meter per second square. So I will make sure that these numbers are in SI unit. This is equal to minus 4.9 T square. Okay. What will happen to minus and minus both sides? They cancel out. So T square becomes 0.235 over 4.9. t becomes plus minus 0.235 over 4.9. Okay, so what should be the answer here? I am getting this t is 0.21899, okay, large number here, second. So I can approximate t is equal to 0.2219 second. Okay, one more thing here, I have not taken minus sign because time is not negative. Time is always positive. Alright, so I am not taking minus sign here. So this is the correct answer. This is the reaction time. Okay, let's do another example. Example 2.9. A projectile is fired from the top of a building at an initial velocity of 35.0 meter per second upward. So V initial, that is upward here, is 35.0 meter per second, and this is fired from the top of the building. The top of the building is 30.0 meter above the ground. The height of this building is 30 meter. This is 30 meter. Okay, from top to bottom, the height of this building is 30 meter. The motion is shown in figure. Okay, this is figure number in your book. Don't worry about this number, but this figure number corresponds to this figure. Find A, the maximum height of the projectile. When it goes up, what's the maximum height it achieves? Alright, how much maximum height it achieves? B, the time for the projectile to reach its maximum height. So from this top of the building to maximum height, how much time it takes to reach to the top? C, the velocity of the projectile as it strikes the ground. So when it comes here and hits the ground, what's the velocity here when it is hitting the ground? And the last part, the total time that the projectile is in the air. So total time from the point you throw, and then it goes to the top and comes back to the ground. Total time, how much time from it is in the air? Alright, from top of the building to the ground, how much time it stays in the air? Alright, so it will be total time to go to the top, and from the top come back to the ground. Okay, that's the total time we are looking for. Let's do this one by one. A part, maximum height. Okay, there are three equations. V final is equal to V initial minus GT. V final square is equal to V initial square minus 2G delta Y, and delta Y is equal to V initial T minus 1/2 GT square. So we are looking maximum height. It means that we are interested in delta. Okay, we have initial velocity. Okay, if we try to use this equation, we need time to go to the top, from the top of the building to the top of this projectile in the air. We don't have time, so we cannot use this equation, the third one. Let's try to use the second one. Let's try to use the second one. What we can do? We have V initial 35.0 meter per second. V final, when the projectile reaches to the top, when it achieves the top position, what's the final velocity is going to be? Gravity is slowing down when it goes up, and the velocity goes down, down, down. At the top, the velocity becomes 0. So you can write this at maximum height, final velocity, V final is equal to, this is final velocity is equal to 0. Okay, so using this one, so using V final square is equal to V initial square minus 2G delta Y, okay, so what happens here? At the top, this is 0. 0 square is equal to 35.0 square minus 2 times 9.8 delta Y. Delta Y is looking from the top of the building to the point where the projectile reaches to the top. From the top of the building to the maximum height is where the final velocity of the projectile is 0. I write this delta Y as Y max. This is 0. The square is 0. 35 square is 1225 minus 2 times 9.8 is 19.6 Y max. Okay, so if you simplify this, 19.6 Y max is equal to 0.0 1225. So y max is what? 1225 divided by 19.6, and that gives you y max equal to how much? 62.5 meter. This height is from the top of the building, okay? From this point to this point. How about the height from the ground? If the same question says that find the maximum height of the projectile from the ground. If the question asks the maximum height of the projectile from the ground, so what we need to do? From here it is 62.5 meters. So from here how much it will be? You need to add 30 meter more, because the height of the building is 30 meter. So maximum height of the projectile from ground will be equal to 30 meter plus what? 62.5 meter. This is equal to 92.5 meter. $30 meter plus 62.5 meter is 92.5. Let's do the B part of the question. Let's do the B part of the question. It says the time for the projectile to reach its maximum height. So how much time it takes from the top of the building to go to its maximum height? How do we do this? Again we have three equations. V final is equal to V initial minus GT. This has time and this one has time. I know delta y from the previous calculation. I can insert it and I can get the answer. But this one looks quite easy. This one looks quite easy. So you know that at top final velocity is 0. We know at top final velocity is 0. So using V final is equal to V initial minus GT. This is 0 is equal to V initial is 35.0 minus 9.8. T is from the top of the building to the maximum height, and so I can write T as this TR, T suffix R. T suffix R means time to rise time. From here to here, that's the rise time. Okay. So 9.8 8 T rise is equal to 35.0. So this gives you T rise is equal to 35.0 over 9.8. And this comes, so T rise will be 3.57 second. The B part was time to reach to maximum height. Okay. What is C part? The velocity of the projectile as it strikes the ground. We know V initial is 35.0 meter per second. The starting point is here. And now the end point is what? End point is the ground. Okay, what's the velocity here? And how to do that? So we are looking for V final. Okay, when it hits here, V initial is 35.0 meter per second upward. V final we are looking for. What we have here, this is starting point and this is the end point. How much is the net displacement between initial point and the final point? The net displacement is delta y is equal to, from this point to this point, from top of the building to the ground, is minus 30 meter. Okay, from here, and no matter where it goes and comes back, but if you look at the starting point and if you look at the end point, the delta y is going to be minus 30 meter. We are looking for V final. So right now we don't know how much total time it takes. So again we have three options. V final is equal to V initial minus GT. That is not being used because we don't know the time, total time. The only option is left is this one. We have V, we are looking for V final, we have V initial, we have delta y is minus 30 meter. So using V final square is equal to V initial square minus 2g delta y, and this is, I can say V final when it hits the ground, I can give the name Vg. Okay, velocity when it hits the ground, Vg as V final. V initial is 35.0 square minus 2 times 9.8 times negative 30. Okay, so Vg square is equal to 35 square is 1225. This minus and this minus becomes plus 2 times 9.8 times, this is 588. Now this gives you Vg square is 1813. So Vg is equal to plus minus square root of 1813. This gives you Vg is equal to plus minus 42.579. Vg is equal to plus minus 42.579 meter per second. Okay. Now you have to decide which one is correct. We should take plus or minus. Now you can see this decision is not difficult. When it is hitting the ground, it is going towards minus y-axis. So we have the correct answer will be minus. So Vg is equal to minus 42.579 meter per second. This is approximately minus 42.6 meter per second. The total time that the projectile is in the air. How to do this one? Let's see that. So starting point is here, goes all the way up and comes back to the ground. Okay, we are looking time from here all the way to the up and back to the ground. How to do this one? Again delta. So this is total time the projectile is in air. Okay, we are looking for this one. Delta y is, this is starting point and this is the end point. In between the delta y is how much? From starting to end, it is, your reference point is here, reference is here. From here to ground, it's going, if you just look at this point and starting and end, the net displacement is minus 30 meter. Okay, minus 30 meter, minus because it is in negative y direction. So again we have three equations. We are looking for time, so we cannot use this one. Alright, we have two choices, this one or this one, this equation or this equation. If we use this equation, I have to use V final that we have calculated in the previous part of this problem in section C. Okay, the velocity of the projectile as it strikes the ground. You can insert that number here. You know already V initial, and you know G is 9.8 meter per second square, and then you can find the time. It's not a problem. I would like to use the third one only simply because I don't want to borrow information from any other section of this question. Alright, for example, in your test or quiz or any exam, if I ask only this part, D part, so the problem, if you try to use this equation, then you have to find V final first and then you can insert in this problem. Now, so let's use delta y is equal to V initial t minus half gt square. This is minus 30 is equal to, this is 35.0 t. Now the t is the total time, okay, from the starting point and goes all the way up and comes back to the ground, the total time. So I would add a suffix tt t sub t, t suffix t. This t suffix t means total time, minus 1 by 2 times 9.8 t suffix t square. Okay, so this becomes minus 30 is equal to 35.0 t minus 4.9 t suffix t square. Let's move this side, this 4.9. So if we move this side, it becomes plus 4.9 t suffix t square. If I move this one 35t this side, it becomes plus, becomes minus 35t suffix t, and minus 30 is already there, so minus 30, the whole thing becomes 0. This equation looks like, you might have learned in your math class, if you have ax square plus bx plus c is equal to 0, this is called quadratic equation. The solution of this equation is x is equal to minus b plus minus square root of b square minus 4ac divided by 2a. Okay, so compare this and this. A is 4.9, b is minus 35, c is minus 30, and in place of x there is tt. So the solution is t suffix t is equal to minus b, minus, what is b here? Minus 35 plus minus square root of b square, b is minus 35 square minus 4, a is 4.9, 4 times 4.9 times c, 4ac, so c is how much? Negative 30. Okay, this is negative 30 divided by 2a, 2 times a is 4.9, 4.9. Okay, so t sub t equals minus minus becomes plus 35 plus minus 35 square is how much? 35 square is 1225. This minus and this minus becomes plus, plus 4 times 4 times 4.9 times 30, this becomes 588 divided by 9.8. So this becomes t suffix t is 35 plus minus approximately 42.6 over 9.8. Okay, this equals, now we have to make a decision. Should we take plus or minus? Now if we take plus, the whole thing on the top, 35 plus 42.6, it comes a positive number. Okay, since time is always positive, so we can accept that solution. If you take minus, then 35 minus 42.6 will give you a minus number here, negative number, and your solution will be negative. As I said, time is always positive, so we cannot accept the negative number here. So the correct solution will be TT is 35 plus 42.6 over 9.8. Okay, or you can write 35 minus 42.6 over 9.8. We have to discard this one. Discard. So TT is equal to 77.6 over 9.8. That is equal to 7.918 second is approximately TT is equal to 7.92 second. Let's do another example. A ball is thrown vertically upward with initial velocity 30.0 meter per second from ground. Find number one, say A, the maximum height of the ball, B, the time it takes for the ball to rise to the top of its trajectory, C, the total time that the ball is in air, d, the velocity of the ball as it strikes the ground, if the position and velocity of the ball at time t is equal to 4.00. So a ball is thrown vertically upward with initial velocity 30.0 meter per second from ground. So we are throwing the ball from the ground. V0 is 30.0 meter per second. So it goes all the way up. This ball goes all the way up and then comes back to the ground. Okay. So I can draw like this. So it comes back to the ground. It comes, in a straight line. So it's going vertically up and coming back vertically down. So the A part, we need to find maximum height. Ground. So starting is here, and for maximum height it comes to the top. What will the velocity at the top? The velocity at the top, if you see here, it slows down, and it comes to rest. So at the top, final velocity is 0. Final velocity at the top is 0. Okay, so we can use V final square is equal to V initial square minus 2G delta Y. V final is going to be 0. V initial is 30.0 square minus 2 times 9.8, and delta Y from the ground to the top, you can say this height is Y max. So this gives you 0 is equal to 900 minus 19.6 Y max. So this gives you 19.6 Y max is equal to 900. So this gives you Y max is equal to 900 divided by 19.6, and so Y max will be equal to 45.9 meter. Let's do the B part of the problem. the time it takes for ball to rise to the top of its trajectory. B, time to rise to the top of trajectory. So this is the whole trajectory from starting, goes all the way to the top and comes back to the ground. So time to rise from the ground to the top of the trajectory, how much time it takes. Again, at top, v is equal to 0. Final velocity at top is 0. Okay, so using v final is equal to v initial minus gt. At the top, v final is 0. This is 30.0 minus 9.8. T, I can put this t as t suffix r. T suffix r means rise time. So 9.8 t suffix r is equal to 30. So t suffix r is equal to 30 over 9.8. That gives you 3.06 second. Let's do the C part. The total time that the ball is in air. The total time the ball is in air. So ball is going from the ground, going all the way up, comes back to the ground. Okay, that's the total time we are looking for. So in this case, starting point is the ground and the end point is the ground. Okay, so delta y between starting and end, both is ground, is going to be, in this case, delta y is going to be 0. So using delta y is equal to v initial t minus 1/2 gt square, this is 0, is equal to 30.0 t. This t I am writing as t suffix t, means total time. T suffix t is total time from ground it goes all the way up and comes back to the ground. That's the total time, t suffix t, minus 1/2 times 9.8 t suffix t square. So 0 is equal to 30 tt minus 4.9 tt square. 4.9 tt square is equal to 30 t suffix t. So 4.9 t suffix t square is equal to 30 t suffix t. What happens here? 1 of t suffix t can be cancelled. 4.9 t suffix t is equal to 30. Now this gives you T suffix T is 30 over 4.9, and if you calculate, you get T suffix T is equal to 6.12 seconds. Okay, did you notice something? What was the time to go to the top? The time to go to the top was 3.06 seconds. It will the same amount of time it will take to come back to the ground. That is 3.06 seconds. So the total time is the time to go to the top and time it takes to come back to the ground, and 3.06 plus 3.06, that again gives you 6.12 seconds. Alright, so if your starting point and the end point is same, so the total time is the twice of the time to go to the top. Alright, if your starting point and end point is different, then you cannot do this. Like in previous example we did for the building, if you throw something from the top of the building, okay, and it comes back to the ground, so your starting and end point is not same. So in that case you cannot do the twice. Alright, so this is only true when your starting point is ground and it comes back to the ground. The end point is same as ground. Let's do the D part of the problem. The velocity of the ball as it strikes the velocity of the ball as it strikes the ground. We are looking for this. Again, in this case, delta y is equal to 0 because starting point is ground and it is coming back to the ground. The end point is ground, so delta y is 0. So what we can do now, we are looking for final velocity, so we can use v final square is equal to v initial square minus 2g delta y. V final is the when it comes back to the ground, so you can write vg square. V initial is 30.0 square minus 2 times 9.8 times 0. So this gives you Vg square is equal to 900. This whole thing becomes 0. So Vg is equal to the square root of 900 plus minus. I need to accept one answer, either plus or minus, but we have to make a correct choice. Okay, which one is going to be correct? See, when it is coming towards the ground, it is going towards minus y-axis. So Vg will be minus. So Vg is equal to square root of 900 is 30 minus 30 meter per second. Okay, if you throw with 30 meter per second, okay, from the ground, it will come back with 30 meter per second towards the ground. The last one is part E. The position and velocity of the ball at t is equal to 4 seconds. The position and velocity of the ball at t is equal to 4.00 second. Okay. We can find position using delta y is equal to v initial t minus half gt square. So delta y is, I can write as y at 4 second, y4, y suffix 4, this is y suffix 4 is equal to 30 times 4 minus 1 by 2 times 9.8 times 4 square. So y4 is 120 minus 78.4. Okay, so y suffix 4 is 41.6 meter. 6 meter. Velocity we can find by using v final is equal to v initial minus gt. So v suffix 4 at 4 second is equal to 30 minus 9.8 times 4. So this gives you v4 is 30 minus 39.2. So this gives you v4 is minus 9.2. It is giving you minus 9.2 meter per second. It means that at fourth second this projectile is coming downward. Okay, it is moving downward. So this minus sign means it is going downward. Okay. Thank you.